Action.
Okay, so 1905, along comes this famous person, Einstein, and so he's working in a world where Planck has recently come up with this idea of quantization of light from Blackbody radiation. They come up with this E equals HF equation, and we've got this problem with the photoelectric effect that different coloured lights seem to affect the higher the frequency of the light, the higher the energy of the emitted photons, and there's like a cut-off frequency below which no light's emitted. So Einstein's like, I reckon I've got it. He reckoned that E is HF minus phi. And so he just put together the ideas that were around to solve this problem. So what does all this mean? Well, the HF, we know what that means. What does the HF mean?
It's the joules seconds.
6.63 times.
Energy of light.
Energy of the light. Energy of the light. The E over here is the kinetic energy of the electrons. So hang on, we've got energy equals energy minus, what's that phi going to be?
Energy.
Energy of what?
Heat. Light.
Not heat.
Light.
What do we have to do? Where are those electrons?
In the
Metal.
In the metal, where do we want them?
Out
Out of the metal, what do we have to do?
work.
Work. It's the work function. Good.
Oh god.
Yo.
Yeah, we probably guessed it.
Thigh. Is thigh what?
Phi.
Thigh.
Work function.
Oh,
Thigh is part of your leg. Phi is work.
but your leg does work.
So energy is energy minus energy. So the work function depends on the particular metal. Every metal has a different work function. So the work function is like how much energy do we need to ionize electrons from that metal surface. Okay, so this is where the first time we see light being thought of as a particle. So Einstein's, the big breakthrough that he made is he said to explain this photoelectric effect, we have to stop thinking about light as a wave. Light is not a wave in this situation. Light is a shower of particles. We're showering the metal surface with these chunks of energy. We're going to call them photons. And each individual photon carries E equals HF, like joules of energy. And so rather than a wave washing up on the metal surface, it's like firing a missile at the metal surface. So wave kind of delivers a whole lot of energy, but it's spread out across the whole surface. Whereas if you think about a missile being fired at a beach, if that hits a bit of driftwood, that bit of driftwood's going to be blown off the beach and back into the sea, and that's exactly what's happening to our photoelectrons that are being like blown out of the metal surface and fired off towards the collector plate with kinetic energy. And the kinetic energy that they've got is the amount of energy carried by the photon minus however much work we had to do to separate them from the metal surface. Now the explanation is easy once we stop thinking about light as a wave.
Oh yeah.
Cool.
Very cool.
Start thinking about it.